Okay, question 15. So Nicola, a darts player, is practicing hitting the bullseye. She knows from previous experience that she has a probability of 0.3 of hitting the bullseye. Nicola throws 8 practice darts. Using a binomial expansion, we want to calculate the probability that she hits the bullseye 3 or more times. So we are given the binomial distribution in the formula sheet. Here it is. Okay, but what this doesn't show us is how to set up a binomial distribution. So if we let x be number of darts hitting the bullseye, and then x has a binomial distribution. Now it's n, so here that's the number of darts she's going to throw, so 8, and then the probability, so here 0.3. Right, so we want the probability that x is greater than or equal to 3. Now, make sure that you know how to use your calculators to do this, because it's going to save you so much time, and it really is something you need to know how to do. So, we can't work out that probability directly, but what we can work out is the probability that x is less than or equal to 2. So the probability that x is greater than or equal to 3 is 1 minus the probability that x is less than or equal to 2. So the probability that x is less than or equal to 2 is what our calculators can work out for us. Okay, so I have a Casio class with something or another, so I'm going to take you through how I would do it on this. Hopefully it's similar to the calculator that you guys have. So first up, I would press mode. That brings up this menu. I would then press 7 for distribution. That brings up this menu. Now we don't want binomial PD. You use that to work out single probabilities. So for example, the probability that x is equal to 2. But we want the probability that x is less than or equal to 2. So we need to scroll down to this screen, and then we want binomial CD. Now the C stands for cumulative, so it adds up the probabilities up to and including the probability for our value of x. So press 1, then we get a choice of list or variable. We want variable, so press 2. And then it comes up with this screen. Put our values in, press equals, and we get our probability. Magic. Okay, so if we take that probability to 3 decimal places, we know then that the probability x is less than or equal to 2 is 0.552. So, the probability then that x is greater than or equal to 3 is 1 minus 0.552, which is 0.448. Cool. Okay, then for part B, Nicola throws 8 practice darts on 3 different occasions. We want to calculate the probability that she hits 3 or more bullseyes on all 3 occasions. So, this is a lot more simple. We are talking about successive events. So, all we do is the probability that she hits 3 or more bullseyes cubed. So, it's just 0.448 cubed. Now, again, if we take that to 3 decimal places, we will get 0.090. Cool. Okay, then for part C, we need to state 2 assumptions that we have made for our distribution to be valid. So, binomial distribution only works if events are independent. So, we have assumed that each dart is independent of every other dart. So that would be one assumption that we have made. Now, the other one, let's think about this. The reason that you practice is to get better. So we have also assumed that the probability of Nicola hitting the bullseye has not changed, which in real life it might. If you practice something, theoretically you get better at it. So we have also assumed the probability of hitting the bullseye has stayed as 0.3.